In question 5, you are asked to sketch a graph of y equal to x plus 4 over x for x positive. And part 2 is supposed to find the area of the region bounded by the curve in part 1 and the line y equal to 4. And the region you call it S. And then you're supposed to find volume of the solid S when it's rotated completely about the line y equal to 5. First, we learn how to sketch the curve y equal to x plus 4 over x. To sketch a curve, you can work out dy dx. You look for possible turning points, maximum point, minimum point. Dy dx is 1 minus 4 over x squared. And if you set dy dx to 0, if you set this to 0, you can solve for x. And then you can also find d2y dx squared. d2y dx squared will give you 8 over x cubed. And because you write x positive, d2y dx squared is definitely positive. If d2y dx squared is positive, then you suggest to you that for x more than 0, the curve should be curving this way, because second derivative is positive. So it means probably you see this curve like this. So that's what you have in chapter 2, slide 95. Next, we will set dy dx to 0. If you consider dy dx equal to 0, it will be same as 1 minus 4 over x squared is 0. So it's same as 1 equal to 4 over x squared. So that means you should have x squared equal to 4. X equal to plus or minus 2. But because you consider x positive, you write x equal to 2. If x is 2, then because second derivative is positive, you can say that x equal to 2. d2y dx squared is actually 8 over 2 cubed. Is positive, so implies minimum point. So you should have minimum point at x equal to 2. Then you can solve for y. Y will be 2 plus 4 over 2 is 4. So it means 2, 4 is minimum point. And just as I mentioned, because second derivative is positive, it must look like this. So the curve probably look like this. For x more than 0, you look like this. And that's how you get this part. That's how you get the red curve. Because it's minimum point at 2, 4. Minimum point at 2, 4. So here is actually 2, 4. And then you can look at the question. You want to find the area of the region S bounded by the curve y equal to x plus 4 over x and the line y equal to 5. Since you read the line y equal to 5, so you consider y equal to 5, right? So that means you equate x plus 4 with 5. Because you read the curve x plus 4 over x, you read the line y equal to 5. So that means you should consider x plus 4 over x equal to 5. And then this will give you this quadratic equation, which you factorize, you get x equal to 1 and x equal to 4. So which means the line y equal to 5 will cut at 1 and 4. So that's how we get here is 1, here is 4. So this is the region S. So you're supposed to find the area of S, And to find area of S, what you can do is you consider area of rectangle. You consider area of the whole rectangle. Area of whole rectangle. This length is 4 minus 1. Here is 1, here is 4. So this length is 3. 4 minus 1. The height is the y value 5. So we take area of rectangle, then minus area under the curve. Area under the curve is this part, which is integrate from 1 to 4 x plus 4 over x dx. So we take area of rectangle minus area under the curve of x plus 4 over x from 1 to 4. Then you get area S. So that's why it's 3 times 5. area of rectangle minus integrate 1 to 4 x plus 4 over x dx. Integrate x will give you half x squared. Integrate 4 over x give you 4 log magnitude x. And then you sub in 4 and 1 for x. You get 15 over 2 minus 8 log 2. Next, part 3, you are asked to find the volume of solid when S is rotated completely about y equal to 5. And to do that, right, you have to know that if you rotate about y equal to a, then the formula is integrate from a to b pi fx minus a squared dx. So in this case, y is the line y equal to 5, right? So you should consider fx minus 5 whole thing square, then pi integrate from 1 to 4 dx. So that's why to find the volume of the solid form by rotating S about y equal to 5 is pi integrate x plus 4 over x minus 5 squared dx, because we make use of this result. If you rotate about y equal to a, then it's fx minus a whole thing squared. Then integrate from a to b dx with a pi outside. So that's why you consider pi integrate from pi in bracket x plus 4 over x minus 5 whole thing squared dx. And then you can expand this out. To expand this out, because there are 3 terms, you can group this as one term. Then you take it as is x minus 5 squared. Will give you bx squared minus 10bx plus 25, right? So this is the bx squared term. So you take bx to be x plus 4 over x, then minus 10bx plus 25. So you just group 2 of the terms x and 4 over x together, and then you can expand this out again. X plus 4 over x squared will give you x squared 8x 16 over x squared. After that, you do the integration, sub x as 4 and 1, you get 57 minus 80 log 2 as answer. So remember, you have to use this formula. You have to use this formula because you are rotating about y equal to 5. The question asks for rotating about the line y equal to 5. And this is the final answer.